Welcome everybody to Euclid's proposition number 26. In this proposition, if we have two triangles and two angles and the side between those two triangles are congruent, or we have two angles congruent and one of the sides not between them are congruent, then the triangles themselves will be congruent. So this is our angle side angle and angle angle side congruence properties. Now let's take a look at why they'll be true. So let's begin by supposing that we have two triangles ABC and DEF. And also let's suppose that angle ABC is going to be congruent to angle DEF. Side BC is going to be congruent to side EF, and our angle BCA is going to be congruent to our angle EFD. Now, we'll want to do this proof by contradiction, and so because we want to show that our segment here, AB, is going to be congruent to our segment here, DE, let's first suppose that they are not going to be congruent. So since they're not going to be congruent, then one of them must be longer, and so we can take that segment AB is going to be longer than our segment DE. Now, by Euclid's proposition number 3, we are actually able to construct the point G, which subdivides our line segment AB, so that one of the shorter line segments, say GB, is going to be congruent to our line segment DE. And so now, if we draw our line segment GC, what we then have is that our line segment GB is going to be congruent to our line segment DE, and our triangles GBC and DEF will be congruent by side angle side. And that was our proposition number 4. But from our triangle congruence, this means that our angle BCG right here is going to be congruent to our angle EFD right here. But our initial hypothesis was that our angle BCA was going to be congruent to our angle EFD. And so, since they are both congruent to our angle EFD, it means that our angle BAC is going to be congruent to our angle BCG. But because we had that G was not equal to point A, it means that our angle BCA is going to be made up of our angle BCG and our angle GCA. But then this would have to mean that our angle BCA is going to be greater than our angle BCG. And so what we have is that our angle BCA is going to be congruent to angle BCG, and we have that angle BCA is going to be greater than angle BCG. But then having an angle being the same size and an angle being bigger than another angle gives us a contradiction. And so this means that our original assumption that we even had a point G was wrong. And so what that means, that our segment AB has to be congruent to our segment DE. And so now, because we have our segment DE that's going to be congruent to our segment AB, now we are back in our usual case. Triangle ABC has to be congruent to our triangle DEF by our side angle side congruence property, which was our proposition 4, as was to be demonstrated. Hope you guys have enjoyed this. Now let's take a look at the other side of this proposition. Now once again, let's suppose that we have two angles of our triangle congruent, So we have angle B up here is going to be congruent to angle E, and angle C down here is going to be congruent to angle F, and in addition, one of the sides not between those angles, so let's say side AB here is going to be congruent to our side DE over here. Now we want to do the same proof by contradiction that we did in the first case. So let's suppose that our side BC is going to be greater than our side EF. But now, once again, invoking our proposition number 3, we have a way to construct a new point H, so that for this line segment BH, it's going to be congruent to our line segment EF. And so by our side angle side congruence, we have that our triangle ABH is going to be congruent to our triangle DEF. And so this gives us that our angle BHA is going to be congruent to our angle EFD. But by our hypothesis, we said that EFD was also going to be congruent to our angle BCA. And so what we then have is that our angle BHA is going to be congruent to our angle BCA. But now proposition 16 says that because angle BHA is going to be an exterior angle for our triangle AHC, that angle BHA has to be bigger than either one of the opposite interior angles for our triangle. And so then in particular, BHA is going to be greater than angle HCA, which is the same as angle BCA. So now we have that our angle BHA is going to be congruent to our angle BCA, and we have that angle BHA has to be greater than angle BCA. Once again, giving us a contradiction. And so what went wrong was our initial assumption that point H cannot actually exist. And so what we have is that our line segment BC has to be congruent to our line segment EF. And so what we have is that making our segments BC congruent to EF, that we now have triangle ABC has to be congruent to our triangle DEF by our side angle side congruence property, as was to be demonstrated. So I hope you guys have enjoyed this proposition, and I will see you in the next one. Take care.